recording now. Okay, welcome. I am Ryan Holger with TEC. Thank you guys again for joining us on another webinar. If you didn't know, we're doing tons of these. We've been doing webinars for, over 10 years, usually like one a month, one a week sometimes when things are crazy. But right now we're doing like 5 a week because there's so much going on in terms of what we can educate you guys on and what you have time to learn. In any case, the webinar this particular day is residential load estimating. We also have a webinar this afternoon for commercial online ordering. So if you're interested in ordering parts, compressors, belts, that kind of stuff online, which has been very popular lately, trying to reduce the person-to-person contact opportunities. If you're interested in that, join us this afternoon at 2 o'clock. tecmungo.com, click on training, and you can see all the webinars there. All right, so we're going to show you guys a residential load estimating tool that only takes 5 minutes. So hence, this will only be a 5-minute webinar. No, I'm just kidding. I talk a lot, so it'll probably be almost the whole hour. But the tool itself only takes 5 minutes. The first time you do it, maybe it takes you 15. By the time you do your third job, you should be knocking these out in 5 minutes. So before we get too far into it, I do have some slides of some stuff to show you here so you understand how the tool works and some of the things you have to do to comply with code and all of that. But before we do that, I'm going to actually show you the tool so you can see how freaking easy it is. And then hopefully that makes you so excited that you want to just like sit around and watch me for the next 45 minutes. So switching over my screen here to my web browser. This is the tool itself. There's a company called Energy Design Systems, EDS. They build and maintain this tool that we utilize here at TEC. I did mention that it is a free tool. It is not actually free for everybody. If you go to their website and you want to subscribe to the tool, it's $120 per year. However, for TEC customers, we do a bulk purchase. So if you look on their website, they got this discounted thing for bulk. We do a bulk purchase for like thousands of seats, so we can give free seats to our customers, you guys. More on that later. But for right now, let's look at the tool itself. So the way the tool works, at a minimum, you only have to do one thing, and the whole load calc happens. And that's it. That's put the address of the home on there. So I'm actually going to use my house just because I'm lazy and I know my house and I have my information. If I do that and I don't change anything, now we're going to talk about things you might want to change to get a more accurate load calc. But if I did nothing, it tells me that my cooling load is 46,000 BTUs, my heating load is 88,000 BTUs. I'm done. I have a load calc, right? Now, I'm going to make this more accurate and show you that this still has a lot of safety factor in there and it's causing my load calc to be a little bit oversized. But if I just walked into someone's house, they probably would have had a 100,000 BTU furnace and probably a 5-ton air conditioner. And maybe because of this, I could put in a 4-ton air conditioner and maybe even go down a little bit on the furnace size. Once you see me tweak some of the settings in here, you'll see it gets even better than that. But that's literally how fast it can be, literally 1 minute. So if we go back to our slides to talk about a few things here, and then I'll show you how to tweak the load calc and make it more accurate, if you will. And by the way, if you guys have questions as we go, as always, type them down in the bottom right-hand corner in that question/chat box, and I will check that periodically to check and see if we need to answer any questions. So you can do it as fast as 1 minute, and you get a load calc answer that way, which is great. You can go in and dial things in deeper, which I'm going to do here in a little bit, and that'll get me a more accurate load calc. It may take me 5 minutes to do that, which is why I call it a 5-minute tool. But you can see just by changing a few things on my own house, I got a more accurate load calc of 33,000 BTUs. So now I'm down to a 3-ton air conditioner and 62,000 heating. And that's even a little bit oversized. You guys that have been on my other webinars or classes know that I have a 60,000 BTU furnace, and it's fine even on polar vortex day. So you can get even tighter on these load calcs by dialing in some more of this information, which we will do. So what goes into a load calc? The information you need to put into the load calc, geography is important, which is why EDS uses the address. That way they can pull in the geographical weather data, and they can use that as a starting point so you don't have to go look it up in a table, or so you don't have to go guess at it, which is even worse. In this case, for this slide right here, I'm using 72 as my indoor heating temp and 2 degrees as my outdoor temp. I'll show you why I use those particular numbers on this particular slide. I'll show you that in a minute. But right now, that's the numbers I'm using. For heating loss to the house, the main contributing factor is transmission losses. That is the heat of your house heating up the wall, heating up the interior of the wall and the insulation and whatever else you have, heating up the exterior of the wall, and going to the outdoors. The amount of heat that transfers to the wall is a function of the resistance of the wall, the R value of the wall and or windows, and the delta T across the wall assembly. In this case, my delta T is 70 degrees. Infiltration is also a factor, but if you guys were on the webinar on Monday, you'll know that I'm going to encourage you to really, really minimize that infiltration rate for anything that's been built certainly in the past 10 years residentially, and probably even longer than that for a lot of houses. That's all we look at on the heating side. We don't look at the solar gain on the heating side, because the worst case scenario for heating is that it's dark out and nobody's home. So people don't matter, lights don't matter, sun doesn't matter. Those things are all irrelevant for a heating load calc. Cooling load calcs are much more complicated because we do have to factor those things in. So worst case for heating is nobody's home and the lights are off. Worst case for cooling is everybody's home and the lights are on. So I have to factor those things into the discussion. What are those things for internal loads? Residentially, it's typically people and lights. We factor in that. Typically what we do is we count 2 people for the master bedroom and 1 person for each additional bedroom. So if you have a 3-bedroom house, we'd assume 4 people in the load calc. Would be a normal thing to do. Lighting used to be a pretty big load. It's actually been diminishing because of not just the CFLs, but now more importantly, the LED bulbs. There's like pretty much no heat output. I mean, you can change an LED bulb, grab it with your hand while it's on, and it's fine. You never would have did that with incandescent and probably not even CFL. The other things on this list we don't normally look at for residential load calcs. It's more commercial. We would pay attention to that because residentially you're not doing much of those things. And even if you have a computer, it's probably a solid state laptop, so it doesn't have a lot of heat coming off of it. And cooking, you don't do a lot of, although the past 2 weeks you probably have. So there's a little bit of internal gain, and then the external gain we got to look at as well. So we have the transmission again. Now in this case, instead of a loss, it's a gain. Heat's coming into the building. It's still a function of how good is my wall and the delta T. In this case, 89 to 75, so I have a 14-degree delta T. Whereas on the heating, I had a 70-degree delta T. Pretty big difference in the Midwest, obviously. Those gains on the cooling side are much smaller than the losses on the heating side. So for that reason, when you do your load calc, your heating load will always be bigger than your cooling load if you're here in the Midwest. Well, you have those transmission gains through the wall and the roof and all of that. We also have solar gain, because worst case scenario is it's a sunny day. The solar gain is what's going through the window, through the glass. A little bit of it reflects back off the glass, but most of it goes through and it lands on a surface, and that radiant heat gets converted into air-based heat. And then once again, on the infiltration side of the equation, it's pretty minimal. There is some there for infiltration and ventilation, but it's a lot less than you probably think it was in the past. When I start tweaking some of the numbers on the software tool, which we'll do here in a couple minutes, one thing to keep in mind is that energy codes regulate much of the states in the Midwest here. Indiana just switched to the current IECC 2018. Illinois has already been on that for a while. Wisconsin does not use the current IECC. They have a really old one that they use, but they also have the Uniform Dwelling Code, which is going to regulate some of the exact same things, and we'll talk about that. Michigan's on the 2015, and for the purposes of energy code, for the purposes of load calcs, it's the same exact information as 2018. So all 4 of these states are basically in sync on what you need to do from a load calc standpoint. Minnesota's a little bit older, but it's pretty similar. I know a couple of you guys are from Minnesota, and some folks are from the Kansas City area. For the most part, Missouri and Kansas are like the Wild West. There's not much from a statewide code standpoint, but municipalities themselves do have some of these types of codes. And if you're in an area that doesn't have an energy code that's telling you how to do this, I would encourage you just to follow the energy code that we're talking about today anyway, because it's just good practice. So 2 things that I'm going to pull out of the energy code that we're going to use in our load calc information. One is, what should the indoor design temp be? And there's some argument on this because there's 2 different numbers mentioned in the code. This section here is not what we're going to use. This is what you got to set up your programmable thermostat for. Programmable thermostats are required by code, and when you install them, you got to set it for no higher than 70 heating and no lower than 78 cooling. That's what you set the thermostat for, but that is not what the code requires you to design based on. The code is going to require you to design for indoor temperatures of 72 heating or less if you want to, and 75 cooling or higher if you want to. Most of you don't want to do less and higher. Most of you want to do like 72 for cooling. That is not allowed by code. And if you guys were on the webinar on Monday, we went into great detail on why that is, because there's a massive dehumidification penalty in addition to energy. So 75 is the lowest you can design the cooling for. If you don't believe me, go back and watch Monday's webinar. So 72 heating, 75 cooling are going to be my default numbers. It's also telling me here that I need to design for ACCA Manual S, which means how I size my equipment, and ACCA Manual J, which is how I do my load calc. Two things about that. ACCA Manual J is where I'm going to get my weather data from, so I'm going to show you that in a minute for the various states that you guys are in. And the other part of this I want you to pay attention to is it says ACCA Manual J or other approved heating and cooling calculation methodologies. We're going to come back to that statement later on, so just kind of keep that in mind here. ACCA Manual J is automatically approved. Other methods can be done if you can justify to your local authority that your method is good. So from a weather standpoint, I'm going to throw up a couple different states on here that I saw some of you guys logged in from. A lot of you are from Illinois, which is where I'm from. I live in Aurora. My heating design temp for ACCA is 1 degree. Now, if I look at the ASHRAE data, it's like -5. The data that we're following is not the same from ACCA and ASHRAE. There's some slight differences there. But in any case, it's similar. Chicago, it's very similar. I think it's +1 degree for ASHRAE right now for O'Hare, and it's +2 for ACCA, so it's really close. But in any case, if you're at O'Hare Airport or nearby, 2 degrees is your heating design temp, 89 is your cooling. Not 91, not 93, not 95. Those are not your design temps. 2 degrees for heating, 89 for cooling. For you guys in Indiana, this is your chart here. I highlighted South Bend because I just had to kind of pick something, and I saw some of you guys were from South Bend. So South Bend, it's actually 5 degrees for heating and 88 for cooling. So it's not quite as extreme as Chicago, but pretty similar weather data. Not quite as extreme, mainly because South Bend gets the directional wind flow coming across the lake, and the lake is a giant heat sink, so you don't have quite as cold temperature and you don't have quite as hot temperature. You get more snow though, but you don't get quite as extreme temperatures. For people up in Michigan, I saw some of you guys are from Southwest Michigan, so I grabbed Grand Rapids as an example there. 6 degrees heating is your design, 86 for cooling. Minnesota, I couldn't even fit on here. There's so many different weather stations in Minnesota. They lapped over onto multiple pages. But in any case, Minneapolis is the one I picked just to show you. It's -8 is your design temp. I know a lot of you guys do -15 based on talking to you. That is not correct. It's not correct for ASHRAE, and it's not correct for ACCA. I don't know where the -15 comes from, but just like in Chicago, everybody tells me -10. I'm like, no, it's 1. But in Minneapolis, -8 is your heating, 88 is your cooling design. And I saw there were some guys from Kansas City, so I pulled that one up. Your design temp is 5. So oddly, your design temp is the same as South Bend, which is significantly farther north. But on your cooling side, 93 is your design temp. Once again, I know a lot of you guys use 95. I would encourage you to stop doing that and use 93. Wisconsin is the weird one because Wisconsin has their own amendments to those numbers. So Wisconsin, instead of 72 heating, 75 cooling, Wisconsin requires by code you only heat to 70 indoor temperature. And they don't specify anything on the cooling side, so we'll default to the energy code default of 75. So 72 and 75 for pretty much everywhere in the country, except Wisconsin, 70 and 75 are your indoor temps. Now, Wisconsin also amends the ACCA weather data for the outdoor temp. So if I took Milwaukee as my example, it would be 2 degrees heating, 87 would be my cooling design temp. However, because of the Wisconsin amendments on those, I'm actually using -10 and 89. So it's supposed to be 2 and 87, but I'm going to use -10 and 89 when I do my load calc. So my code official is happy with those numbers. Now, what that means for Wisconsin compared to everybody else on this call is if everybody else is doing their load calc and they're doing a good job and getting pretty accurate and they decide to round up a little bit, that's a decision they might make. In Wisconsin, definitely don't do that because you already have added rounding up into the load calc by putting in these incorrect outside air numbers to comply with code. So John has wrote in a question. We have a few towns around us in Illinois that actually require we size the furnace to -10 outdoor. Do they override the code? No. Those particular jurisdictions are out of compliance with the code. Legally, they're not allowed to police something different residentially. Commercially, big cities above 1 million people can, i.e. Chicago, for commercial. But for residential, nobody's allowed to deviate from the code. No town in Illinois is legally allowed to have their own energy code. So they are not supposed to be telling you to design it for -10. The coldest thing I can see for Illinois on here is -4 up in Freeport. So nobody should be going -10. Now, when reality strikes, if your inspector is telling you to do that, and that's the way to get your accuracy permit, I know what you guys are going to do. You're just going to push it through and get it to happen, but they should not be telling you that. They are probably working with very old local codes, and they don't understand the state code overrides them. It might be different in other states. I'm very familiar with how the code works in Illinois, but other states may, locals may have more power than the state. I don't know. We'll have to look at that. All right, so let's go back over to my load calc over here that I just did for my own house. That was my 1 minute effort, my pretty lazy 1 minute effort. Now what I could do is I can go and dial more stuff in. So let me take you through this tool and show you the stuff that you can change and how you would in fact change it. So I put my address in, it pulled it up, said 46,000 cooling, 88,000 heating. I have a halfway decent load calc. Not accurate, but way better than just looking at the current tag on there. I should also mention that this tool only works residentially. You cannot use it on a commercial building. It only works residentially. It only works on single family residential, and it only works on existing homes. I probably should have mentioned that up front. So it doesn't, if you have a condo building, this tool is not really going to be helpful to you. The tool doesn't have the ability to take into account like a condo where you have a neighbor on the left, a neighbor on the right, a neighbor above and below you, and that are insulating you. A condo has very little heat loss and heat gain because you typically only have 1, 2, or 3 exterior things touching outside, whereas a single family home, you have 5 sides touching the exterior. So this only works on single family homes and only on existing homes. I mean, you could use it for residential new construction, but there's 2 problems with using it on new construction residential. One, it's not going to be able to find your address yet because your address doesn't exist. So you have to force everything in manually, which is fine. But 2, residential new construction, you're also going to need a NACA manual D for duct design. So you might as well just use a different tool that does manual S, manual J, and manual D all in one crack, such as RightSoft. But for quickie stuff that's existing on furnace, boiler, air conditioner, heat pump changeouts, this tool works just fine. All right, so stuff that I can tweak on here. So the first thing is it shows me the house geographically from Google Maps. And I can say, yep, that's my house right there in red. That's the one. If for some reason it showed a different house picture, wrong spot. You got something wrong. The address is wrong or something weird happened there. The other thing that could happen is it's telling me my square footage down here, 2,836, which is roughly my square footage. If it shows up as 1,700, that means they couldn't find your address with the tool. For whatever reason, it's not showing up correctly in Google Maps or the other stuff. They couldn't find your address, so they just threw 1,700 in there just for having something on there. We asked them last year to put that in big red writing because it used to say nothing, and you just had to magically know that 1,700 was wrong. Put it in big red writing so that way if you see 1,700, you know you got to go do a little bit more homework on that one. If it has your house and it finds it and everything's correct, but let's say the square footage is wrong. It says I have, I don't know, 2,000 square feet. Maybe it's pulling data before they added that addition on. So you can change that number by typing it in here or moving the slide bar if they have different square footage than what we have here. By the way, the square footage number, it's coming off of Zillow data, which is pulling it from tax record data. So if it has the wrong square footage here, it's probably also wrong on Zillow and also wrong with your township assessor. So just point that out on there. All right, so I look at my house here, and right now it's saying that most of my sun exposure is probably on the east side. It's making a guess at that. That's not really accurate in my house. Most of my exposure is on the south side. So I'm going to click on that. When I did that, you see that it changed my load calc a little bit. So when I was on east, it was saying I needed 46,088 heating. I click on south, and now it's saying 41,088 heating. The heating didn't change. Why didn't the heating change? Well, I just told you earlier that a heating load calc doesn't account for solar because the heating load calc is happening at 2 a.m. when it's dark out. All right, so the heating won't change no matter what I do with the windows. If I say I have no windows or no sun exposure, it would make no difference on here as far as the sun goes. The thermalness of the windows, that does come into play, right? The U value, R value of the windows, that would come into play, but not the sun coming through them. So I know my house gets the most sun on the south because this side of my house and that side of my house both get beat on by the sun in that scenario. I don't get a lot in the west because I have a pretty large pine tree there that's shading a good portion of the house. Plus, there's a porch with an overhang that's shading a good portion of the house. North doesn't get any sun, obviously. In the northern hemisphere, we don't get direct sunlight. So my choices really are east, southeast, south, and southwest at my house to say who has the most sun. And my neighbor's house does shade me partially on the southwest. So I've kind of limited myself down to east, southeast, and south. It's not a huge deal. You saw it only changed it by a few thousand BTUs. Not a big giant jump, just a little bit. So when you're looking at someone's house, it's not even like a big giant calculation. You're just kind of glancing at it, saying, "Oh yeah, there's trees over there, so I'll make a note of that. I won't tell if the sun's on that side or that's being shaded by an office building or something, right?" So I can make those tweaks there, get my load accurate, a little more accurate. I also have this section down here for square footage of window area. It's trying to use that Google Earth data to try to figure out which sides of my building have the most window area. I've been finding that this is usually pretty wrong. It's not very accurate on here. It's just a guess that this tool is making. But in my case, I don't have hardly any. I have no windows on the northeast at all, and very few that would be touching the north. But yet north has a pretty big number over here. I have most of my windows are south and southeast and southwest exposures. So I could tweak these and make them something else. I can go measure the windows if I want to get anally detailed. I could just leave it if I don't want to get anally detailed. But just for sake of argument, it says 206 on the south side, 144 on the north side. I'm just going to change those to something totally different just so you can see the numbers change. So if I change the north to 15, you saw my load calc changed, right? It went from, 41,000 down to 39,000 on the cooling, and it went from 88 to 84 on the heating. So as I dial that into different numbers, it's going to give me different answers, right? So my heating load calc went way up in that case. I didn't measure my windows. I probably should have before I did this webinar, but I'm just going to take some guesses at my windows right now just to get something decently close to what I actually have. It's going to be pretty rough numbers here just to make something happen. All right, let's just say those are my windows, just for argument's sake. And by the way, there's these little arrow question marks on stuff. You can hold it over the question mark and it'll give you a little more detail. That's something they've added relatively recently also. Like I said, this tool is 10 plus years old. We've been using it that long at TEC and our customers have been using it. But they do make enhancements and tweaks to it. The calculation methodology is pretty much the same, but they add stuff to make it easier to use. And one of the things that we ask them to do is for each of these factors down here is to put question marks, little help boxes on each one, so it's very clear what that thing actually means, right? So here, this one's pretty obvious, right? You didn't really need help on this one, but it's telling you to enter the square footage of the glass on each side of the residence. Shading, same kind of thing. You're estimating the shading percentage. It's not applying it to a specific size here, a specific side of the house. It's just kind of generic. Some software tools you can apply the shading per window, which obviously gets you more accurate. This is meant to be a 5-minute tool, so it's not that detailed, right? But I could say I have a different shading factor, and just for argument's sake, we'll look at our number change, 43,870. If I change it to 10, let's see what it does. All right, so now my load went up from 43 up to 50. If I tell it I got a lot of shading, let's say there's a bunch of trees and everything, now my load went down to 34, right? I'm going to leave it about 30% because that neighbor's house and that pine tree in front, I'm feeling that it's probably about that much shading on my main sun sides of the house. So there's that part of it. By the way, I didn't mention this. So one cool thing they've done in recent years too is when you scroll down, it keeps the load calc current numbers on here. It used to scroll up and you had to go up and down with it. Now they kind of freeze there so you can see them at all times. Almost like if you're doing TurboTax up in the corner, it's always telling you what your refund's going to be. As you change something, you see how it worked on your refund. Same thing's going to happen here. As you change something, you can notice what it's going to do on the math and how it's going to affect the house. By the way, they have another load calc tool. I mentioned this one here that they charge $120 for that we give you for free. They have another one that's a little bit more expensive, $180 a year. And what it does is it does 2 load calculations side by side. You do the one on the left side, you do it for the load calc of your current situation. And then on the right-hand side, you do it for the improvements you're going to make. Are you adding insulation? Are you sealing the house? Are you doing duct sealing? Are you putting in a more efficient furnace? What are you doing? So it tells you the load with the original and then the load on the second, and it also tells you the operating cost. What's the operating cost currently on the home, and what's the operating cost when I make these changes? So as you propose something to a homeowner, you could say, yeah, we're going to put in the new furnace, and we're going to seal your ductwork, and this is why we'll be able to put in a slightly smaller system because we're sealing your ductwork, and this is what the energy savings is going to equate to for the ductwork and the new furnace. So it actually is pretty cool. We do offer that one to TEC customers free of charge as well. So both the load calculator that I'm showing you today and the auditor, and if we have time at the end today, I might show you the auditor too, just a real quick version of it, or maybe we'll do it as a separate webinar. But that's a pretty cool tool also that you can get for free from TEC. And I'm saying TEC, that's our parent company. Some of you guys are in territories where we do business as Excelsior. That's the same company as far as the parent company goes. So the tool can be available to you as well. You can check on a box here that has age of construction. And that just basically gives you some default starting values for our values. It's pretty crude. It's just a guess. They have no idea how they actually built your house, right? They're just guessing, well, back then the code was this, so they probably did that, right? So I usually don't even mess with that part there, and I just go in and adjust the insulation values myself if I want to change something. You can do the insulation values as R value or U value. I don't know who the hell wants U value. There's some engineer out there that likes that apparently, but I just leave it as R value. Then you can start tweaking other stuff too, like indoor design temp. So if you put show on here, it tells you that you should follow your local code, what the normal ranges are, and what the typical default is, 75 in this case, because that's typically what most codes are. My house, we actually keep it at 77. So I'm going to tweak mine from 75 to 77, and we're going to watch the cooling load change there. So not a major difference, right? Went a little bit of a change, not crazy huge, right? But I can make that a little bit different. My outdoor design temp, we said for where I live is 89, right? But if you change stuff, let's say for argument, you're doing some old school thing and you're like, I always use 95. That's what I'm going to do. You click in 95, click somewhere else, and it'll do the math to make that change for me. So it went up for, call it almost 5,000 BTUs. I'll go back to 89. So we get a more accurate calc. So it does make a difference on the sizing. Grains of moisture is a little bit harder one. This has to do with the indoor moisture content. Some of you guys prefer to think in humidity percent, but humidity percent isn't really mathematically easy to work with. So software programs like to do it in grains of moisture. If you're not sure what the difference is or how that works, we did do a psychrometric training module last week and this week. You're welcome to watch those on our website as well, and you can learn a little bit more on how that works. But that will help dial in my latent load a little better. So if I know something weird's going on, and there shouldn't be anything weird going on unless I have like a swimming pool in the house. But if for some reason I said, no, it's like 48 grains of moisture, man, it's really crazy high. Okay, if I make that change, it's going to make a difference in my load calc. All right, I'm going to leave mine at 34, which is pretty normal. Indoor design temp, if I was following Illinois code, I could go as high as 72. I can't go any higher than that. Now, I don't have to go to 72. I could go to 72. When I actually did my own load calc for my house, I put mine at 68 because that's what we normally set our thermostat for. So I went lower in my case. And you see it changes a couple thousand BTUs on the heating load there. Outdoor winter design temp. This is pulling in 3 degrees for where I live. The ACA data, if I went back and looked at that, was for Aurora, where I live, Aurora, Illinois, it's 1 degree. So I'm not sure where it got the 3 degrees from. In my ACA manual, in my defense, is from 2014, so maybe there's a slightly newer one, so maybe that's why it's 3 instead of 1. But in either case, if I dial it in as 1, just to show you what it looks like. So it's 1,000 BTUs difference on my heating load. Not crazy big, but a little bit different. If I go to -10, like many of you like to do in Chicago area, maybe didn't update. What the heck? Did it update or did I not see it? Let me go back to 3. And this, people, is the problem with doing the live demo. All right, so it's catching up to me now. All right, well, in any case, it's calculating slowly as I change some of this stuff here. That's, I guess, the only downside of having it always on here. When I had to scroll back up on the old version, by the time I scrolled up, everything was recalculated. But in this case, maybe it's a little bit slower. Sensible heat ratio. Once again, if you don't know what sensible heat ratio is, refer to the psychometric webinar that we recorded last week, and you can learn about that as part of the discussion. 0.75, 0.77, that's pretty normal for a desirable sensible heat ratio. That means 75% of my load is sensible and 25% of my load is latent. And you can tweak that if you're trying to do something specific. Number of residents. In my house, we have 6 of us, so I would bump that up to make it accurate with my house. If I didn't know how many people were living there, I would say, oh, it's got 4 bedrooms. Okay, I would make it 5, which is what you would do for a 4-bedroom house. 2 for the master, 1 for each other one. But I happen to have 4 kids, so I'm going to make it 6. Average ceiling height and wall height. All right, so this one is kind of crude as well. Some software programs, you can dial in the ceiling height of every single room, which obviously gets you more accuracy. However, in this tool, a lot of assumptions are made in the background for us to make it faster. That's how it gets to be a 5-minute tool. So it's just one average ceiling and wall height. So in a lot of houses, you might have 9-foot ceilings downstairs and 8-foot ceilings upstairs. So I would tell you just put in 8.5. Right? In my house, I do have 8-foot ceilings upstairs, 9-foot downstairs. But then in the master bedroom, it's a trade ceiling, so it's actually like 9.5. But then downstairs in the living room, it's a 19-foot ceiling. It's kind of all over the board. I'm going to say it's 9 on average. But you can play with that a little bit. Attic ceiling square feet. So in this case, it's assuming that I have a single-story house. It's not been smart enough yet to use the Google Maps to guesstimate that that's a 2-story home. So it assumes everybody has a single-story home, which is obviously not ideal. So I don't have 2,800 square feet of ceiling because I have 2 stories of my house. So I have less ceiling / attic than that. So you can see what they're telling you on the notes over there. But let's say for my house, what would mine be? Well, it's pretty much straight up either way. So the 2,800, it basically would just be half because everything, my house is very square-ish. Except for above the garage. So let's say it's 1,600 square feet. Oops, sorry, it's locked. So if I want to override it, I would unlock it. And now I could say it's 1,600 square feet of ceiling. And that will change my load calc a little bit. R value. So this would be based on the R value they actually have. If you don't know what they have, you can look. If you didn't look or don't have the time to look, the guesstimate on the software tools probably pretty decent. In this case, it's showing 18.87. My walls at home have R19 insulation, and they probably know that based on the age of construction that I had told it previously. They knew that was probably the code back then, which it was. So with, I'm sorry, this is the attic. Timeout. Hang on, Ryan. So R19 was the code at the time my house was built in 2003, but I upgraded my insulation and put R30 in. So it's taking the R19 and it's taking a little bit of penalty for the studs not being as good as the insulation material. So that's why it's showing 18.87 instead of R19. It doesn't really make a difference. It's very close. But my house actually has R30 in the attic. If you're doing a current house, new construction, something built in the past 2-3 years, I think most of the houses are R50 in the attic now. So that would obviously make a big difference on the load calc as well. Wall square footage, it's calculating this based on the square footage of the whole home and the height of the ceiling. So it's automatically doing that auto calc for me, right? But if I had something different, I knew something about the house, I measured it myself, I could then change that. R value, R11 would have been code at the time my house was built. I actually have R19 though, so I could change that. That'll make a little bit difference in my load calculation as well. The U value of the windows, for those that don't know, U value is the inverse of the R value. I don't know why the window guys use U value instead of R value, other than they probably don't want to tell you that your window is like an R1. In any case, lower U value means higher R value because it's an inverse. So that's why as the window panes goes up, the R value goes down. If you know the published U value of the window, and by the way, we're talking about the window assembly, not just the glass itself. But if there's a sticker on there or you built the house so you know what it is, you can do that. If you don't know, and you usually won't, then just go with these guesstimates here of 1 or 0.5 for double pane. So I have double pane, I put 0.5 in there. And you can tweak that to if you have better data, obviously. Here on the solar heat gain, you can look on here. If they have regular clear windows, they're giving a recommendation that it's going to be between 1 and 0.85. Once again, if you have a sticker on the windows, they just bought new windows last year, so they have the spec sheet on it or something like that. Obviously, put in whatever they have for the spec sheet. But if you don't know, you can assume the 0.85 for the clear windows. And if they have low E windows, which I have, then you would go somewhere between 0.6 and 0.4. I forget what my windows are, but I'm going to go with 0.5 in the middle just for right now. And that shouldn't really have any effect on the heating load, but it will affect the windows that I previously told it had solar heat gains over here. So these guys over here that happen to be faced, well, not north, but the south, west, and east windows get affected by that, if you will. And you saw my load calc went down when I did that as well. Floor over unconditioned base. Actually, let me see if we have any questions. Yorman asks, how about 2 system homes? So this load calc tool, once again, is pretty limited, but for a 5-minute tool that's free, you get what you get, I guess. It will do the load calc for the whole entire house, but you would then have to figure out which portion do you want to put in the upstairs system and which portion do you want to put in the downstairs system. So normally with 2 system houses, and I've done a few of them with this tool because I'm, once again, lazy and I don't want to actually do a full load calc with WriteSoft, which is a fantastic software tool, by the way. But I'm lazy, so I will use this tool. And I will, so let's say I'm doing the upstairs system, which I did for one of my coworkers a couple months ago. I used this tool. I did the whole load calc and told him, hey, your whole house needs 6 tons of cooling. You have 2 4-ton systems. In general, your whole house is oversized. Then what I did is I kind of just limited down the square footage, and because it was the 2nd floor, I left the roofing where it was, and then I kind of cheated and said that this section over here, floor over unconditioned basement, was nothing because the 2nd floor's basement is really the 1st floor of the home, which is conditioned. So I kind of cheated it that way to kind of force it in. It's not really designed for that, but you can kind of game it a little bit. Mario asks, is the % shading for the entire building or area with the most exposure? So the shading is not well defined here. It is meant to be an average shading for all of the sides of the house except the north side. It's not going to get you the best result that way, the most accurate result, but other than building every window individually like you would with a full software tool, it's kind of the best that you can really do. So it's the whole house except for the north side. If there's a bunch of trees on the north side, it doesn't matter. Trees on other sides, it's going to make a difference. And you kind of have to just take an average swing at it. Mohammed says sensible / latent. I think he probably said that when we were talking about sensible heat ratio. Dave, I got to expand the screen to see your question. If you have an English basement, do you add half of the 1st floor square footage? What's an English basement? Is that like where instead of being fully underground, it's like it's an 8-foot basement and like 6 feet are underground and 2 feet's above ground? It's probably something like that. There's going to be some values in here that we can tweak here to optimize that. Okay, David said, yeah, it's something like that. So let's go back into the software here and we'll get to what will probably help you with that. So floor over unconditioned basement. What's an unconditioned basement? You can look at the code to get those kind of definitions, or you can take your own definition of it. An unconditioned basement is basically, I would say it's a basement that you did not put diffusers in because you're not trying to heat it and cool it, right? So if it's a finished basement, that's not this, right? An unconditioned basement would be one where you've done nothing to it. You didn't insulate any of the walls. You didn't do anything to intentionally put diffusers down there to try to heat the space. It only gets heated by like the waste heat off of the side of the duct, right? That would be an unconditioned basement. And it tells you here some little notes on there, but you got to kind of eyeball it. So in my case, that's actually pretty close to what my house is. I think my basement's like, I want to say like 1,600 and something. So let's say 1,650 for argument's sake. And then the R value, I don't really have any R value between my 1st floor and my basement. It's just the construction materials themselves. So carpet, tile, plywood, right? So that's why the R value is so low. 5 is actually probably pretty normal for my wood and tile area. Actually, it's tile, the wood subfloor, and then I have a gap there, and then a dropped hung ceiling. That gap actually does a pretty good job as an insulator as well. Although, since I heat my basement, it doesn't really matter, right? Because my basement's heated, so really floor over unconditioned basement for me should really be 0. And then the R value doesn't matter because my basement is in fact heated. Basement below grade, square feet of basement, that's where I should have put the 1600 in. R value of basement walls, I don't know my R value, but part of my wall, my whole basement is underground except for 1 foot of it. And the top 3 feet of the walls I have insulated. Basically, I've insulated where there was wood studding, but not where there was concrete. So the R value of 10 is probably pretty decent guess, and not having better information or doing math, that probably will be what I'm going to leave it at. Percentage of wall below grade, in my case, it's more like 80% is below grade. Floor over unconditioned space, like how much feet do you have that's above your garage, which is unconditioned or partially conditioned, or over a crawl space, which is unconditioned or partly conditioned. I have some parts of my house that are above a garage and 2 parts that are above crawl spaces. And I'm going to estimate those around 600 square feet. I don't know why they have this as U value. It should be R value. That was one of the things we asked them to make. 0.1 U value doesn't mean anything to me. I have to actually do the math, say, okay, 1 divided by 0.1, what the heck is that going to be? And look at my calculator to say, oh, that's an R value of 10. All right. My R value below my floor is actually better than that. I'm going to say it's 0.8 U value. I would like them to change that to R value. Temperature of space. This one's kind of crappy because I have my spaces above a garage. I have a bedroom above the garage. And then I have a living room and a family room that are above crawl spaces. The crawl space is about 60 degrees. The garage is about 40 degrees. So I'm just going to split it just for argument's sake, just to put something in there. And if you guys have been paying attention, every time we tweak something, the load calcs change. It may take a little bit of time, like there you go, it finally changed there. The load calcs do change when we change some of these values. A lot of the basement stuff doesn't really have any effect on the cooling load. It's mostly heating load related. And then the solar stuff doesn't have any effect on the heating load. It's mostly cooling load related. But they're all having an effect somewhere. If I didn't have an unconditioned crawl space or basement below grade, that means by definition I put this thing on a slab. So these would be 0, these would be 0, and then I would have some square footage here for the slab. Or maybe it's a combination. Maybe I have a slab over part of it, and I have a basement in another part of it, so you can split the square footage between those things. Just remember when you're splitting up those square footages, or even if you're doing it all as one, it's not the square footage of the whole home, it's just the square footage of that first floor, basically, right? Because the second floor, he's above the first floor, and he's being insulated by the first floor. So if you have a 2,000 square foot home that's 2 stories, don't say 2,000 square foot above the basement or above a slab. It's probably 1,000 above the slab and 1,000 above on the second floor. So only put 1,000 in. This one is these next 6, these last 6 on here are a sloppy mess. This is where all the load calcs get jacked up because people have no idea what these numbers are. None. I don't even know what the numbers are in my house. People have no clue. So they typically do one of 2 things. Either they put in something really conservative or they, quote unquote, use the software default because the software company must be pretty smart about it. Yeah, the guys that write the software are smart, but they have no freaking idea what's going on at your house. They just threw numbers in there, and these numbers are definitely not accurate. And every software tool I've used from every manufacturer that I've used it from, these numbers right here, these next 6 that I'm going to show you, they always put them in super conservative, right? So it's not really pretty accurate here. So a couple things here, and we asked them to define these terms because before I just said it and there was no definition. So last year they actually added the definitions on here because a lot of us were assuming the duct loss percent was duct leakage. Probably because we do a lot of aerosol at our company, so we got excited about that. And we're like, oh yeah, duct leakage, 10% is low. We know statistically it's like 31% is the average or something like that. But it's not just duct leakage. it's all thermal losses. So duct leakage is a factor of that. The thermal insulation or lack of on the ductwork is a factor of that. All right, so the surface area of the duct matters. If you have improperly sized ducts and it's causing there to be restriction and hence less airflow delivered to a space, you could factor that in there. So it can be used in a lot of ways. So it does make it a little bit of a sloppy discussion, and it forces you to guess a little bit. My house, all the ductwork is inside the thermal envelope. I have nothing in any attics, and I do have a little bit of footage in some of those crawl spaces that's cutting through the crawl space, but that's 60 degrees in those crawl spaces. I don't have a vented crawl space. I have an unvented crawl space, so it's pretty minimal in a 60-degree space. And my duct is pretty tight because I've aero sealed it. So if I was trying to guess at this, 10% is really high for my duct system. For a lot of houses, it might be okay. But for my house, I'm going to lower it down, and I'm going to guess it's at 4. Not because of any science. I'm just guessing at 4. Infiltration. Now, this is also a difficult number to know what it is either. This is how many air changes per hour. They put different defaults in for cooling and heating. Because of the delta T difference across the wall assembly, you do get a little bit more infiltration and heating in most scenarios. But these numbers are also conservatively high. If you hold your little mouse over there, it tells you a little bit about what infiltration is, yada, yada, yada. If you actually did a blower door test on the house, remember I mentioned there was 2 software tools. One that's the regular load calculator, which I'm showing you today, and one that's the Energy Home Auditor. That Energy Home Auditor allows you to actually put the blower door test data results into the auditor tool, and it'll calculate these air changes for you. So if you guys have a blower door and you're doing that as part of your design and or sales process, you should definitely use the auditor tool for both energy calcs and for your load calc, because you can dial that in a little bit nice that way. But in my case, the other thing I would probably want to say, so right now it's showing infiltration and then it's showing ventilation rates. What's the difference? Infiltration is uncontrolled leakage into the home that I didn't plan, that I didn't desire. It just happened because the house was not tight, right? And that's pretty common. Ventilation is air that I intentionally brought into the home. I sucked it in through a duct on purpose. Either I could be bringing that in through an ERV and then conditioning it, or I could be bringing it in raw, which is what we mostly do. So I have a 6-inch round coming into the backside of my furnace, which I actually do at my house. Actually, I think it's a 5-inch flex duct coming in from the outdoors to the return side of my furnace, and I'm sucking air into that way. When my supply fan runs, it pulls return air and outside air in. If I am running outside ventilation air in, and I am running my fan continuous, which I'm probably doing because the code requires that to happen, then I shouldn't have any infiltration into the house. I'm sucking air in, and I'm positively pressurizing the house. So once you come down here and say, yeah, man, I'm going to put in, for my house, it's probably around 75 CFM, I think is probably what I calculated mine at. When I do that, I'm going to change these infiltrations to 0. Now, not that it's impossible to infiltrate, but if I'm bringing 75 in, and I'm probably not running my bath fans, and if I am, one of my bath fans is only around 40 CFM. So unless I'm running 2 bath fans, I'm still under positive net pressure in the house. So I'd have to be running multiple bath fans or the bath fan plus the dryer or something like that. So my infiltration is going to be nothing most of the time. You want to be slightly conservative, throw a little 0.1 on there, which is what I normally do when I do my own house. So I'll do it like that. All right. And you can see my load calc now. When I made all those tweaks, it's telling me that I have 32,000 BTUs cooling. So I'm kind of in between. It was 32,000. Then when I changed that infiltration, now it's down to 25,000, we'll call it. That's a pretty big difference by changing those infiltration numbers. And at first I didn't do that. When I did my previous load calcs, the defaults were 0.6 and 0.8. And all I did at my house is I said, okay, well, I got fresh air, so I'm going to bump mine down to 0.4 and 0.6. And that's how I ended up with a 3-ton system at my house. So 32,000 BTUs, basically a 3-ton system. But if I was to do my load calc again, I definitely would go lower on those infiltration rates. And I probably would be able to put a 2-ton system in. Well, damn, Ryan, how do you know how do you know the infiltration? Well, 1, I probably should do a blower door test. But 2, the other thing is, I've been in that house when it's been high 90s, even 100 degrees. I've lived there for 20 years, And at 100 degrees, my air conditioner, at the time I had a single stage unit, now I have a 5-stage, but the single stage unit, it still cycled on and off on a 100-degree day. And the highest I've had in the past couple of years with my 5-stage, I want to say we had like a 96 or 97-degree day. So let's just say it's 96. That is 7 degrees above my design temp for outdoors. And that thing still did not need stage 5. It needed stage 5 coming out of setback. But once I got up to temperature or down to temperature, it didn't need the 5th stage. So I still had extra capacity in that 3-ton. So I could probably go with lower numbers in those cases. The other thing it's going to do for you, actually, let's see if we have any questions here. So Eric says for a tri-level style home with a basement, so it's essentially a quad level house. I can visualize that. The basement is fully below grade. The family room, 1 bed, and bathroom are on a slab about 4 feet above grade. But I use the slab portion of the family room, bathroom, bed area. All right, so honestly, what I would do is that full basement down there, I would ignore that. Don't put that square footage in at all. That thing is insulated by so much dirt on the outside of those brick concrete walls that it's basically the ground temp, which is probably like 60 degrees most of the year. So it's like the outdoors are only 60 degrees, which means you barely need heating and you barely need cooling. So I would not even count the actual true basement in any of the calcs. And then I would just use my lower tri-level. Let's go back up here. A lower tri-level, and then I would do it here as I do my lower tri-level as a basement below grade and say that square footage, and then say how much of it is below grade. You said 4 feet, so that's probably 50% below grade. That's what I would do on that scenario. Doug mentions blower door is the only way for accurate load calcs. I agree with you, Doug. The blower door is going to give you the most accurate way to calculate the load, for sure, because this infiltration number is a big deal. It makes full tonnage size differences on people's systems, and everybody puts in too much infiltration. When I do commercial load calcs, I put in 0 infiltration, literally 0, because in those cases, we have a pretty large ventilation requirement relative to a pretty small bathroom exhaust requirement. So it's positive pressure. Nothing's infiltrating. Stuff's actually a little bit exfiltrating, if you will. The same thing with residential. The load calc is definitely affected by that infiltration, and Doug is absolutely right. That blower door gets you the most accurate way. I know a lot of you guys don't have blower doors. So for those that don't have one, A, consider getting one, and B, at least start rounding some of these software defaults down a little bit so you're not as grossly oversized on the infiltration. Unless the house was like built in 1890 and never updated, those numbers aren't very good. Then what happens down here after you do the load calc, there's a couple more things I can show you on here. One, you get these pie charts. The pie charts are nice because you can see where this load is coming from. And you can see the ventilation is a quarter of my heating load. And that's after I dialed it down, right? That infiltration is a big deal. If I left it where it was, God forbid, what was it at? I think 0.6 and 0.8. It's going to be like half of my load calc. It's going to be a really big number. It may take a minute for that pie chart to update as well. It still says 67. So when that updates, then the pie chart will update. It updated to 46 because when I deleted the 0.1, it read it as 0, and then I put the 0.8 in, so now it's got to read the 0.8 and do it. All right, so now it's going back upward there. But that pie chart, as that gets tweaked, that pie chart will increase those percentages on here, and we'll get to see that when it's done calculating. But you can see where the heat and cooling energy is being lost or gained. So if you were looking to improve someone's house, this is also a nice thing you could do and say like, oh, well, listen, we got to stop your house from being leaky. We'll do a blower door test. We'll see how leaky it really is, right? Your windows suck, right? You need better insulation. You can kind of tell them where some of these problems are at. And when you use the auditor version of the tool, it helps you dial that in specifically. And you can tell them how much energy they're likely to save from each of the individual improvements you can make. On the cooling side, you can see that my load is dominated by the windows because I had a lot of glass. So that's part of the problem. Whereas on the heating side, when windows are not as big of a deal because I'm only getting the thermal loss, not the solar, or excuse me, yeah, getting the thermal loss, not a solar factor. Whereas on the cooling side, I'm getting the thermal gain as well as the solar gain. So it's kind of a double penalty. It's bigger there. But you can see where those things break out into. And as you do more and more of these, you start getting used to seeing these. And if you come look at it and something's totally out of whack, you're like, whoa, wait a minute. Why the hell is the latent people load so damn big? And you scroll back up and you're like, oh, I didn't put 6 people in. I put 60 people in. Dang it. That's why. Right? The latent load people load shouldn't be half of my total load. You can then put the customer info in. I'm just going to call this one test because I don't know what else to call it. I'm actually just going to leave all that like that. And then say get report, and it'll make a PDF version of this report for the client that you can email to them or print off to them or whatever it is. For you guys that are doing load calcs as part of the bidding process, there's kind of two different schools of thought on whether you send the customer the load calc. One is I send them the load calc, now my competitor knows the load and I didn't have to do any work. Okay, that is true. But on the flip side, your competitor probably wasn't even doing a load calc. So by giving the customer the load calc, it makes your competitor look stupid. And one of the things I might recommend to you as well is that when you're doing the load calc for this customer's home, a lot of us would gather up all the data, go measure stuff, write it all down, and then go back to the office and do the load calc because it would take like an hour. Well, now if I can do this whole thing in 5 minutes, I don't need to leave the house. I would prefer you do this load calc in front of them for two reasons. One, if you leave the house, it just gives them an opportunity to go get more bids. But two, if you do it right in front of them, you can have them buy into the things you're putting in. Oh, Mrs. Jones, I look like when I was up in your attic, you had this much inches of insulation. That's probably about an R30. And then she's like, no. We just had that redone and blah, blah, blah. The guy told me it was an R42. Okay, I'll put R42 in, right? You have them buying into each input that you're putting in. Oh, the square footage, I think it's, about this much for the basement. Like, well, actually, we think it's, all right, fine, whatever you want, Mrs. Jones. So as they're buying into it, then later on when the answer comes out and you're like, okay, you need a 2.5 ton unit. And like, but my old one's a 4 ton. And the other guy bidding said I need another 4 ton. Like, yeah, but we just did the math and it's really a 2.5 ton. And you can have them buy into it better if they actually were part of the process. Anyway, here's the report that spits out. It is 5 pages long. This same report can be used if you needed to give it to an inspector as part of your furnace changeout project or your AC changeout project. It has your info, and I notice I didn't type that in. It just knows my info from my login profile, so it already has that on there. Normally it just says company name, but in my case, I changed my company name to TEC-Ryan, and then I used to have a Carrier Bryant ICP version of this. Now the tool's all blended into one, so I probably should rename them, but I have 3 different logins, which is why it shows it that way. In any case, yours would just say your company name, Joe's Heating and Cooling, or whatever it was. The customer's information, so they know that it's accurate, right? And then the customer's name and phone number, and then the inputs that we put in, right? Here's my glass. Here's my design conditions that I use. The inspector is going to want to see that to make sure you're using the ACA data. He may come in and be like, no, dude, it's supposed to be 1 degree, not 3. You're using the wrong version of the ACA manual J manual. Okay, I'll change it to 1 degree. No big deal, bro. Right? Make sure you didn't design it for some crazy high heating or crazy low, non-code compliant thing. What data did I put into my load calc? And then what are my actual loads and where are they being distributed to? I didn't mention the diversity thing, and we can go back to that and look at it as well. I'll go back and show you the diversity. Actually, I'll just do it right now. That diversity thing was happening while we were up here as well. I probably should have showed it to you originally. When I first did it, there was like a little hill over here, and everything else was below the line. If you look at the note down here, if the dark green line exceeds the light green line, consider variable or zoned equipment. What they're telling you there is because of the way your windows are orientated around your house, it's likely you're going to have difficulty cooling one side without overcooling the other side of the building. So they're saying you probably want to look at zoning that, meaning put in a zone dampered system or put in zoned ductless mini split system, or at a very minimum, maybe you go to at least a variable speed blower furnace to help, just because you can run the fan continuously then and get a little bit better circulation. I don't really buy into that all that much, but there is some benefit to that. Or maybe you want to do a poor man zoning with Ecobee and the sensors, that kind of thing. But originally mine didn't say I needed very much of it, but then when I changed the glass facing area, it did make my hill change on there. So it is recommending zoning, and I do have zoning at my house. I only have it zoned upstairs and downstairs. I would like to have zoned it a little better than that, but that was the easy way to zone it based on my ductwork. And then the very last thing on the report is the equipment selection report. You need this for your ACA Manual S. So Manual J is the load calc. Manual S is the system sizing. So obviously you need the Manual J, the load, in order to size the equipment. But then there's a whole other manual that ACA has telling you how to size the equipment. Some of the highlights of that are you're allowed to oversize a furnace or boiler by 40%. I don't recommend you do it, but you are allowed to do that. But you're only allowed to upsize the cooling by 10%. So if it says that you need a, I don't know, what does mine say? It says I need 23,000 BTUs sensible, 8,000 BTUs latent, so I need like 31,000 BTUs. So I could probably round it up to a 3-ton unit and be pretty close to being within that 10% range. The other thing that ACCA Manual S is going to have you do is you're going to have to go select an air conditioner, or a whole system rather, an air conditioner, evaporator, and fan system that work together to be able to satisfy both my sensible load, 23.8, and my latent load, 8.4. I don't want to have pick a piece of equipment that doesn't take care of my latent properly. So that's really what that ACCA Manual S is. So that's why this part of the report is here for equipment selection. So you can use that when you're selecting your equipment to finish your ACCA Manual S. Airflows are as part of that discussion as well. So it's telling me I need 1,000 CFM for cooling to get those loads taken care of. I need 874 on heating to get those loads taken care of. And then when I set my system up, I'm going to look at those same CFMs as well and use that when I adjust my fan speed or my speed taps or whatever I have. So a couple other things on that. So I had mentioned, let me go back really quick. I have 2 more minutes and I'll wrap up with you guys here. I had mentioned that on this slide that per energy code, you need to use load calcs that are in accordance with ACCA Manual J or other approved heating and cooling technologies. This has been misinterpreted a few times, and some inspectors have said, no, you have to use a software program that is listed on ACCA's website. ACCA software, the website on ACCA software, is there for a very specific reason. Someone paid ACCA to put it on that site, and they are selling it through that site. It's a advertising marketing thing. It doesn't mean it's the only programs that are using ACCA Manual J calculations. So this particular program is not listed on that site because it costs 6 figures to get on that site, which this software company cannot afford to do. So you have to basically tell the inspector it's not on the site. You're true, but I don't have to be on the site. I have to be using ACCA Manual J calculations, which we are. We're using that math, if you will, and that's how we're accomplishing in that. There are a couple things to help you in that regard. One is these notes down here at the bottom are meant for the inspector. So if you have to try to convince the inspector that, yeah, I'm using the ACCA Manual J calculations, I'm just not paying ACCA for it, this is where you can do that. The other thing is, oh, I probably jumped off the site. Dang it. Let me go back to where I started originally. Before I actually put the address in, I have these reports on here that you can print off, and it's a more detailed version of what I just showed you down here. So there's like a little cliff notes on it, but if somebody wants the full reports of those things, you can print those off and hand them to the inspector or whatever. And there's a couple different ones on there because different authorities have stated that this methodology is in accordance with ACCA Manual J. So you can get that on here if you need that as well. All right, let's see if we have any other final questions. Okay, let's see. I gotta make my slide bigger because Muhammad wrote too much stuff. You typed too much, Muhammad. Okay, my question is, what if we increase the percentage of fresh air since there are many options like air-to-air heat recovery options such as Untitled wheels and sensible and latent energy recovery? So this tool, when we're looking at that ventilation infiltration air, so let's say I made the house really tight and then I put an ERV in. So I would drop these leakage rates down. And then let's say my ERV was, I don't know, let's say it's I'll make my life easy. Let's say it's 100 CFM. Well, this tool is going to assume it's 100 CFM of raw air. So that means, in my case, 3 degrees in the winter and 89 degrees in the summer. So if I'm going to be heating that up with the ERV waste heat from 3 degrees up to, I don't know, 50 degrees, I'm going to have to say, oh, well, let's make my life easy. Let's say it's 0 degrees outside and it's 70 degrees inside, and I'm going to take my ERV up to 50 degrees. So I'm raising from 0 to 50 degrees. So that's getting me 50 of the 70-degree delta T 5/7 of the way. So 5/7 of 100 CFM is what I'm actually getting heated up. So that means, this is so complicated, that means 2/7, nothing's happening on, and 2/7 of 100. Right, so I'm going to say basically, what is 2/7 of 100? Make my life hard. I'm literally using a calculator. That's how dumb I am right now. So I would put in 29. It would be nice if you could check a box that said ERV, no ERV, right? But it doesn't have that box. And then I would do the same kind of thing for the summertime to figure out, okay, well, 89-degree day. Actually, I'll make my life easy again. 90 degrees down to 75, 15 degrees delta T. So 2 divided by 7 times 15. What is that? Oh, I don't want that. What would that be? I'd have to know how much I'm heating my ERV up to. So let's say, this is so complicated to do it this way, but let's say my ERV is dropping my 90-degree outside air down to 84 degrees. So 6 of my 15 degrees. So 6 divided by 15, that's 0.4 improvement. That means it's 0.6 not improved for 0.6 times my 100. So I'd still have to deal with 60. So you might do something crude like that. When you start doing that, you're going to notice that there's not really a big difference between putting 100 in here and 60 in here. 40 CFM is not going to change the math that much. So yes, you can get more accurate with that. Yes, it'd be nice if they had a checkbox for ERVs, but in reality, what I normally do is I just put the ERV CFM in there and say, yeah, I'm pretty close. Muhammad also asks a follow-up to that. With pre-cooling the outside air, I assume he means with the ERV, can't we decrease the amount of cooling load? So you don't decrease the amount of thermal energy gained or lost by the house structure. The only thing the ERV is going to affect is this number that I've been changing right here, the ventilation CFM. And that will, in fact, change my heating and cooling load. But it's pretty minor in the grand scheme of things. Sarah asks if this webinar is available to go back again to. Yes, I am recording it right now. So we're good in that regard. It'll be up on our website probably in like 3 hours or so. Dylan asks about the auditor tool that I mentioned. I was going to maybe try to squeeze it in at the end today because I figured, oh, it's a 5-minute tool. How long can I freaking talk about it? Well, here it is, an hour and 5 minutes later. So I will schedule another webinar to go through the auditor tool as well for people that want to see that. Maybe a week or two from now, I'll do that one. Roger asks how you can get access to the software. Okay, so I didn't mention that. So like I said, there's 2 ways you can do it. You can go to the EDS website, which is eds.tech. So it's not a .com, it's a .tech. You can go to that website, and you can come down here, and you could actually register and pay $120 per year per user to do it. Or if you are a customer of TEC, and a lot of you guys that are residential dealers of ours, if you're already are like a dealer of Heil or Bryant or Carrier, Day and Night or whatever, you probably already know about this program. But if you're not, you can get the software program through us. So what I'm going to have you do is contact your individual territory manager for wherever you are in the Midwest, and they will be able to get you set up on this. If you're an engineer and you want to use the software, you're not even a dealer or whatever, that's okay too. Same thing, contact your TM and they'll get you set up with the software. Mike asks, what recommended software tool do we have for residential new construction? I like the RightSoft tool. It is very accurate and very detailed. And with the RightSoft tool, unlike some load calc programs, it'll do the manual J, manual S, and the manual D, the duct design, which I'm going to need to know how many BTUs I have lost per room in order to size the duct later on, right? So that RightSoft tool is fantastic, and they have a graphical version of it now where you can basically on like a digital scratch pad, you draw out the dimensions of the house. It's actually pretty nice. We do have a software class coming up on that in May at our office in Melrose, where the trainer from RightSoft comes into town, which he does every 12 to 15 months. He comes into town and does training, hands-on training with that. It's a 2-day class, and you go through the whole entire software tool. At the moment, that class is still scheduled for May, But the way things have been going with the state pushing stuff out for groups, I don't know if we have to bump that date back or not. But it is currently listed on our website. Brian asks for clarification. If we're a dealer through TEC, do we get this program for free, or does it still cost $120? No, if you are a dealer of our brands of equipment for TEC and you're in our territory here and we work with you, you can get this software program for free. Like I said, if you're looking at my screen right now, down here where it has this big discount for bulk users and multi-use clients, we have that license. So we have literally like 1,000 seats of this. So we give that to you guys for free if you're already doing business with us. And I mean, in our world, if you're using our software tool and you're going to be quoting our furnace and our air conditioner, great. Like, this is a small expense for us to have you do it the right way. And yeah, I do realize that when you do a better load calc, that means you put in smaller furnaces, boilers, and air conditioners, and that means we technically sell less. But we're okay with that. We would rather sell something less expensive to you than have there be problem jobs later because you're complaining about humidity or your customers complaining about humidity or whatever. So we'd rather do it this way. All right, I am well over my time, as I always do. So I'm going to end the webinar. I thank you guys for your time. Reach out to your TM to get usage and access codes to the software. If you don't have a TM, send me a note, and I will figure out who's supposed to be your TM, and we'll get it solved that way. We'll definitely get you guys access. Thank you guys for your time. I appreciate it.